Friends, today I am going to discuss about the first experiment of our engineering chemistry, the potentiometric titration of strong acid versus strong base. Okay, by using potentiometry to determine the strength of the given acid like a HCl, we have to know the strength of the HCl by using sodium hydroxide. So in this experiment, so we have a first part is the aim of the experiment. In this experiment, to determine the strength of the given acid, that is HCl, by using sodium hydroxide with the help of the potentiometer and EMF value. In this experiment, we require some chemicals and apparatus, that is a principle involved in this experiment, and tabular form, model graph and calculation. Let us see, so what are the apparatus are required to demonstrate our experiment. So the first one is apparatus or glassware that required to get the potentiometric titration. Here potentiometer, next calomel electrode, platinum electrode, burette, one of the pipette, beaker, glass rod, measuring jar. So these are the glassware that is required to perform our experiment. And next, the chemicals requirement. So here we require sodium hydroxide. The sodium hydroxide concentration must be known. That means standard sodium hydroxide. Here we are taking sodium hydroxide 0.1 normality, and HCl, that is unknown concentration of HCl. So we have to find out the concentration of HCl, that is unknown concentration of HCl. And third one is the quinhydrone electrode, that is powder type of the material. Quinhydrone electrode, one of the pinch, that means small quantity of quinhydrone is required. Next, here the principle involved in our experiment is HCl reacts with sodium hydroxide, so to form a NaCl plus water molecule. So this is our principle. Next, that is a procedure. So how the procedure will be followed in our experiment. So let us start our demonstration here. In this experiment, we required the instrumentation is potentiometer, and glasswares are, one is burette, next calomel electrode, platinum electrode, pipette and stirring rod. So these are the glassware we are required to demonstrate our experiment. So first of all, let us take the sodium hydroxide into the burette. So first fill the sodium hydroxide in our burette up to the mark, 0 mark, and then take the HCl. So this is HCl. The concentration of HCl is unknown one. So we have to find out the HCl concentration by using the potentiometer. So then pipette out 20 ml of HCl by using pipette into the beaker and add 2 electrodes. So first one is the calomel electrode and next one is a platinum electrode. Dip into the beaker and add a small quantity of quinhydrone electrode into the mixture. So these 2 electrodes fix it to the potentiometer and titrate the mixture by using sodium hydroxide by dropwise drop. That means 1 ml. Every time we have to add 1 ml of sodium hydroxide into the beaker and mix it by using the stirring rod. So all these readings, so we have to make in a tabular form like this way. So this is a tabular form or observation. So that is done by our experiment. So first one is the serial number, next so volume of sodium hydroxide in ml and EMF value. So what are the EMF value that is shown in the potentiometrically? So that can be calculated in terms of millivolts. So millivolts is the units for EMF value. So we have to take in a column in a tabular form EMF in terms of millivolts. Next column is the delta V, that is change in volume in terms of ml. change in volume. That means, so how it is changing? By the first drop to second drop, that is the change in volume. So we have to take in a delta V in terms of ml, delta E. The delta E is the change in EMF value from the first point to second point. So it is called as the delta E in terms of millivolts, and the last column is the ratio of delta E by delta V. Delta E is the change in EMF and change in volume. So there is a one more column. So all these are observation. So we have to take in a 30 readings by adding the sodium hydroxide by 1 drop into the B rate. So that is a reaction will be takes place like this way. HCl reacts with sodium hydroxide, so to form a NaCl and water molecule by the addition of sodium hydroxide to the HCl solution, and you will get a EMF value for each ml of sodium hydroxide. That values are for first ml of sodium hydroxide. Once if you are adding to the beaker, you will get some value. That value may be x1, and by adding of next ml, that is sodium hydroxide, once if you are added to the beaker, and you will get one more value, that value is x2. Like that way, so up to you have to add 30 ml and take that values in a EMF column. All this column, you will get all this column from the tabular form, and this table form, so we have to use in a graphical model. Okay. So these graphs are two types of graphs are there. So first one is graph 1 and graph 2. In graph 1, in a x-axis, so we have to take volume of sodium hydroxide in ml. On y-axis, we have to take EMF value in terms of millivolts. So we will get a graph like this way. So it is called as a sigmoid graph. So at the end point, the sharp drop or sharp fall in the EMF value we will be noticed in the graphical manner. So that value is nothing but the end point of our experiment. So this end point we have to substitute in our calculation like this way. N1 V1 equal to N2 V2, where N1 is the concentration of sodium hydroxide. That value is already known. That value is 0.1 normality.